Mr. Hayes' World of Math. We're reviewing AP Stats. I know I sound like a broken record, but we're almost halfway there. Actually, we are. You've got a rocket launcher set up. The old version of the igniters fail 15% of the time. They make a new one, and they want to make sure that it should be more successful. So the company engineer develops a new igniter. To test the performance of the super igniters, the engineer uses the following process. One super igniter is selected at random and used in a rocket. The rocket launches. They put another igniter into the is selected and randomly used in a rocket, and then you just keep on going. You're going to do this until you have a failure, or until you hit 32 super igniters light successfully and launch rockets, whichever one comes first. Assume that super igniter failures are independent, so one's not going to affect the next. So for part A, if the failure rate of the super igniters is 15%, what's the probability that the first 30 super igniters are going to fail? Won't fail, excuse me. So that is just simply going to be, what's the probability of success? And then you're going to have 20 of those. So we've got the probability of success is 1 minus the failure. So we get 85% to the 30, or 0.85 to the 30th power. So you're going to turn out that having 30 of them happen without any issue is going to be 0.0076. So very unlikely, but we'll get more to that in a second. For part B, given the fact that the first 30 super igniters have successfully launched, what's the probability that the 31st fails or the 32nd fails? So if you come down here, the 31st failing is just going to be 15%. The first 30 we don't care about. Why? Because they're independent. Those 30 up until that point have no bearing on what's going to happen on the 31st rocket. So you've got that. Now, so if we get a failure on the 31st one, there's a 15% chance of that. The 32nd one would mean that we didn't fail the first time, but failing the second time. And so because of there, you're going to have success times failure, which is going to be 0.85 times 0.15, which is 12.75%. We're going to add those together because, much like the tree diagram, it's the same idea. So there is a 27.75% chance that if the first 30 rockets were successfully launched, that you're going to have a failure either on the 31st or the 32nd rocket failure, which ironically is the same thing as the first and the second, as long as, whenever you're there. Given the 30 super igniters successfully launched rockets, is it reasonable to believe that the failure rate of super igniters is less than 15%? And explain. So again, this is, if you can mention alpha levels if you want, as the probability of 30 successful launches is 0.0076 purely by chance, then if the true, I should have added, actually, I could just cross that off, is extremely low, less than 1%, or you could even say less than 5%. It is highly unlikely that the failure rate of the super igniter that this failure rate of the super igniter is less than the 15% that's assumed. Okay, I think I said that correctly. So anyway, so that gives you a basic for what's going to happen. So again, a lot of the probability stuff, and then they're just going to ask you to kind of push it a little bit further. That's it. Hope everything's going well for you. If you have any questions, throw them down in the comments. We'll talk to you soon.